Welcome back. So today we're continuing on our third day of dividing polynomials. Now the awesome thing about today though is we get to start a different method, and actually the method that I prefer. I love synthetic division. Now when you're first starting it, it seems intimidating because it's going to be a brand new setup, a brand new system, but honestly I find it a ton easier than having to do long division. The only little note about synthetic division is it doesn't work in every instance. Synthetic division only works when you're dividing by a linear binomial where the x has no coefficient. So that means x plus a number or x minus a number. If there's a coefficient with the x, it doesn't work and ends up falling apart. So right here shows you the different steps, all right? Rather than me typing them up, I took a snapshot of an example. Now, talking through this example really won't do much good until you figure out how to set up the system yourself. So this is basically a reflection point. So you have a very nice laid out example, but I'm not going to really step through the whole thing because it won't do you much good until you see the problem all the way through. So I'm going to start down here with a brand new example. So the first thing that you're going to do when you're using synthetic division is you look at what you're dividing by. Okay? That's going to give you what I call the magic number. In this case, the magic number is going to be 5. The magic number is always the opposite of what you see in that factor, in that linear term. Okay? And I'm going to offset that value. Then the rest of the numbers I'm going to put are all of the coefficients that I see. So I put 1, -8, 17, and -10 to represent every term of the polynomial that I'm looking at. And now I'm ready to begin my synthetic division process now that I have that set up. In the beginning, you always pull down that first value. So I just pull it down, and now I'm going to multiply that by my magic number. So 1 times 5 is going to give me 5. And I put that in the next column. Whenever you have two numbers stacked on top of each other, you're always simply going to add them. So -8 plus 5 gives me a -3. Every time you get a number down there, you're going to multiply by that magic number in the corner. So 5 times -3 is a -15. All right, well now I have two numbers stacked. So what am I going to do? I'm going to add them up. 17 plus -15 is going to leave me with a 2. Have a number down there again, so now I'm going to multiply by that magic number to get 10, add, and that's going to give me 0. And then I always offset that last number as well. That last number is always going to be my remainder. Now in this case, the remainder is 0, so there is no remainder here. But I start by labeling that because then this is going to be my constant, my x term, my x squared term, so on and so forth. Because once you synthetically divide, I don't just want that list of numbers. I want the actual polynomial you're left with. I have 1x squared minus 3x's and a constant of 2 with no remainder. So that's the polynomial that I have left over after I do that division. So I think it's a lot simpler once you get used to the process, to setting it up this way to solve. So let's do a couple more examples so you feel comfortable with this process. Now, just like with long division, if you have a term missing, you're going to fill it with a 0, all right? So take a look here. My magic number this time is going to be 1. It's the opposite of what you see. And now I start lining up those coefficients. So I have 1x to the 4, 2x cubes, no x squareds, 1x, and I have a -3. All right, now I'm ready to start my process. Drag down the first number, and whenever you have a number down there, you multiply by the magic number. 1 times 1 gives me 1. All right, now I add, which gives me 3, and then I multiply again. So 3 times 1 gives me 3. Add 0 plus 3 gives me 3. Multiply. 1 times 3 is 3. Add to get 4. Multiply. Add. And now that's the end. So I offset that final number. That final number is always going to be the remainder of the problem. Then I start working backwards. That means this would be my constant. This would be my x squared, x cubed, so on and so forth if I had any more terms. So once I finish the synthetic division, now I'm going to convert it back. So I have 1x cubed, 3x squareds, 3x's, a constant of 4, and then a remainder of 1. And remember, the remainder is always put over whatever I was dividing by. So when I divide these two polynomials, this is what I end up having left. All right, one more example before I let you go. Always start here to identify your magic number. In this case, your magic number is going to be -2. Then I start lining up my coefficients. 1x cubed, 2x squared, -4x's, and a 5. All right, so I begin by dragging that first number down, and then I multiply. -2 times 1 is a -2. Add, then multiply. Add, then multiply, add, and I offset that last number. Because that last number is always going to be the remainder. Then I have my constant, my x term, my x squared, and in this case, that's as far as I need to go. Now I write it back as a polynomial. You always have to convert it back to a polynomial. So an x squared, no x's, constant of 4, and a remainder of 13, which means it's still being influenced by what is being divided by. And that's it. So thank you for joining me for those notes. So please make sure you write a summary. Again, maybe a good summary would be comparing this to long division. But whatever you do, just please make sure you write that for me, then come back ready to do your practice work.